Mamadas, vas a ver. Eric, mira. I'm just looking at the souls. Yeah. Kind of cool, right? Good morning, ladies and gentlemen. How are we doing today? Here, put away your phones. Everybody else, put away your phone and your headphones. All right. If you don't have a calculator, grab one because you're going to need it today.
I need that pink one.
Really? Miro, ¿con quién vas a ir a comer, güey?
All right. Joshua, there you are. Good. Achilles, good. Shenza, good. Pierce, good. No, Olivia, Jack, Faith, Skylar, Michaela, no Ben, Ariana, Jasmine, no Jasmine, Steven, gotcha, Irving, got you, Phoebe and Josie, got you, Ding and Dong, got you, Jaden and Joshua, got you, yes, beautiful. So, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Perfect.
Well, it probably didn't. That's why it does like a long time.
It's piecewise. It's just like graphing.
Okay. So, since tomorrow is our test, ladies and gentlemen, question I have for you today is there anything that you would like me to go over? Is there any sort of problem you would like me to do for sure for you today? Yes.
Could you do like one problem of molecular formula?
One problem of molecular formula.
Yes, please. Yeah.
Here it comes.
Oh, I can't take them. What's up?
All right. So here we go, ladies and gentlemen. All right, for a molecular molar or a molecular mass problem, ladies and gentlemen, it starts out like an empirical formula problem. So for this one, ladies and gentlemen, this is about a fat, ladies and gentlemen, and it is composed of 75 or 76.5% carbon, 11.3% oxygen, and 12.2% hydrogen. Okay? And they have to give you this. The molecular mass is 847 grams per mole. So when they give you this problem, ladies and gentlemen, this is the minimum that they have to give you. They have to either tell you how many grams of each thing is in it or the percent that is in there. If we're given a percent, we convert it to grams by doing what? if we're given percents like we are here, we convert them into grams how?
100 grams.
We assume a 100-gram sample. You can assume any sample size you want, ladies and gentlemen. And you would take the sample size times the percents to get grams. The easiest sample size to assume is 100 grams because it takes this 76.5% and makes it into 76.5 grams of carbon. It takes the 11.3% oxygen and makes it into 11.3 grams of oxygen, and it takes the 12.2 grams or 12.2% of hydrogen and makes it into 12.2 grams of hydrogen. Now that we have it in grams, what do we do with everything? Convert it into moles. So for carbon, we are going to convert it into moles by using 1 mole of carbon over 12.01 grams of carbon. Someone work on doing that math for me. For oxygen, 1 mole of oxygen on top over 16.0 grams on the bottom. Someone work on that math for me. And for hydrogen, 1 mole of hydrogen over 1.01 grams. I need the moles that we get from these. Who's got the top one, please? 6.36 moles of carbon. Who's got the middle one?
0.706.
7 what?
1.
Well, give me a few more sig figs in that. 0.7.
06. 25.
Moles of oxygen. And when we take 12.2 divided by 1.01, we get around 11 point what?
I got
12.0?
Yeah.
Oops, that's moles, sorry. Okay, now what do we do?
Divided by the small cylinder.
Which is what?
0.706.
Oh no, sorry. Yeah, on those.
The smallest number of moles.
0.706.
Okay, so what do we get for the top one?
Seems like 9.
It does. I'm hoping somebody will help me out here. There's 15 of you with calculators out there, but nobody apparently cares about the problem here. I'll get the second one. That's 1. 16. Okay, so here's our formula, ladies and gentlemen. C9O1H16. I didn't say it was going to be an easy compound. Okay, this is the empirical formula. That means this is the formula of this fat written in lowest terms. So now that we have done this, what do I need to find? Eric, what do I need to find? You wanted to do this problem.
The empirical formula.
I did. It's right here.
I mean, sorry, not that molecular formula.
Okay, what do I need to do to find the molecular formula?
I forgot. That's what we do.
If I knew what you were talking about, I could tell you what it's called.
Mass something.
The mass something.
Yes. Thank you. What's it?
We've got this empirical formula. To find the molecular formula, we take the molecular formula mass divided by the empirical formula mass. The empirical formula mass for this compound right here, ladies and gentlemen, is 9 times 12.01 plus 1 times 16.0 plus 16 times 1.01. So 108 plus 32, ladies and gentlemen, 140. 0.25. Somebody do the math on that just to check and make sure I'm correct.
Mr. Brandon, I have a stupid question.
Okay, go ahead and ask it.
Where it says molecular and then equals molecular formula over empirical, what is FOE? What does that stand for?
Formula.
Formula? Oh.
To find the molecular formula, we need to know what the ratio of the molecular formula mass to the empirical formula is. The molecular formula is so many times bigger than the empirical.
Okay, I got it. I just didn't know if it's
Nope,
FO
nope,
or
nope.
what.
Sorry, I abbreviate a lot of things that don't make sense. Did anybody confirm that my mass is 140.25 for me, please?
Yes.
Okay, so now we take this 847 divided by 140.25. How many times bigger is our molecular formula compared to our empirical? Someone, please. 6. These two, when you divide them, come out to be 6. Or at least very close, correct? So now, ladies and gentlemen, go away. We take this formula here and everything in it times 6. So that means our molecular formula is C54O6H96. That is the molecular formula of that compound. Questions?
No.
What does that make?
It makes a fat.
Fat.
A fat, like a fat in your body.
Oh.
That's a fat. 54 carbons long, 6 oxygens attached to those 54 carbon, and 96 hydrogens along for the ride.
Wow.
Pretty big molecule.
Very fast.
Questions?
Is there like a review sheet?
Yep.
Perfect.
All right.
That's what I need.
So you're
I did, ladies and gentlemen, for you create a study guide. This is the study guide that is in the Google Classroom. Tells you what's on the test. there will be 6 two-step Moeller conversion problems, starting out in either mass, volume, or particles, and ending up in either mass, volume, or particles. There will be an empirical formula determination that will either be given to you in grams or given to you in percents. There will be a molecular formula determination like we just did. There will be a percent composition problem. There will be ionic compounds in water, and you will predict what happens if they are soluble and if they are insoluble. And you will be writing and naming formulas from an empirical formula that I give you. That is the entire test, not including the bonus questions. So, you wanted a review? Get with a partner, grab a marker, go to any lab station. There is a sheet there that at the top, you are asked to find the empirical formula of one of these 5 compounds. Then there is a molecular formula problem, and there are 6 of them there. Pick any one you want. And when you're done with that, turn it over, and on the back side, find the percent composition of any one of those compounds. Now, if you do not have enough room at your desk or at your lab station, after you do one, call me over. I will check it over. And if it looks good, I will tell you to move on. And if not, I will tell you what to correct in it. I do not have the answers for these, though, ladies and gentlemen. So all I'll be looking at is if your work is correct. Okay? Go to work.